All right, so this is number 41 from chapter 2.3 over on page 128. In this problem, they give you a polynomial and they ask you to go a polynomial equation, and they ask you to verify that x equals 1/2 is in fact a 0. So in other words, we're actually testing to see if x minus, subtract 1/2 from both sides, 1/2 is in fact a factor of this. And we'll see a little more of that in a little bit here. So the way we verify that is we're going to use 1/2 as our k, and then we are going to go ahead and put our coefficients right in here. So we have 2, -15, 27, and -10. And always verify to make sure that we're not skipping. We go 3, 2, 1, and 0. So we're not skipping any. We don't have to put any zeros in here. Now I will go ahead and first drop down the 2. 1/2 times 2 gives me a 1. I add -15 plus 1 and get -14. 1/2 times -14 is -7. So we get a 20 here. 1/2 times 20 is 10. And I get a 0 here. Now a remainder of 0, okay, of 0, okay, means that it is a factor. Okay, so I now know that 1/2 is in fact a 0, or that x minus 1/2 is a factor. Okay, and basically what we're saying here is that x minus 1/2 is equal to 0. So if we were to take 1/2 times our polynomial here, we would get 0. And this, or again, proving that this is a solution to our equation. Now, I divided basically by x here, so I'm going to go down by a power of 1. So if I want to rewrite this equation now, I can rewrite it as 2x squared minus 14x plus 20. And I know that I'm looking for when that is in fact equal to 0. Now, if I want, I can actually go ahead and add in the factor that I had before of x minus 1/2. Okay, I can do that right now if I want. All right, and moving right along, we are looking to factor this polynomial. I'm going to go ahead and take 2, multiply it by 20 to get 40, and I'm looking for two numbers that multiply to get 40 and sum to get -14. Well, after a little bit of thinking, I can see that that's -4 and -10. Okay, so when I factor, okay, I'm going to rewrite that I have x minus 1/2 times, okay, and this is where it can be a little bit tricky. I'm actually going to use a strategy that I've been showing in class for multiplying, and I'm going to use the reverse strategy. Okay. Okay. And again, this is the generic rectangle, and I'm going to say, well, I know that I want to have a 2x squared right here, and I know that this term needs to be 20, and then I'm going to put a -4x here and a -10x here. And I verify that the sum of the area of each one of these rectangles will give me my original polynomial. And in fact, 2x squared minus 4x minus 10x, well, the minus 4x and minus 10x gives me -14x plus 20, okay, is in fact there. Now I go ahead and I simply factor out from the rows here the greatest common factor. So I can factor a 2 out of both of these and an x, and I can factor a -4 out of this one. Okay? 2x times x will give me this rectangle, and 2x times -5 will give me this one. And then I verify that -4 times -5 will give me 20. So I know that if I multiply 2x minus 4, the length of the rectangle, times x minus 5, the width of the rectangle, Okay, that will give me the area, which is equal to the polynomial I was just factoring. Okay, and now that is equal to 0, so the factors are listed here. And if we wanted to find the other solutions, which is one of the things that it asks for, okay, well, I already found x minus 1/2, okay, is equal to 0. Okay, again, using the zero product property here. 2x minus 4 is equal to 0. And x minus 5 equals 0. So this is going to give me my 3 zeros. Okay, I add 1/2 to both sides just to verify, and I shouldn't even need to do this particular step, to be honest, okay, because I already know that this is in fact one of my roots of x equals 1/2. Here I'm going to go ahead and add 4 to both sides, and I get 2x is equal to 4, divide by 2, and I get that x is equal to 2. And then I'm going to add 5 to both sides of this equation. I get x equals 5. So if I want to go ahead and be a little bit more of a mathematician, I can take those 3 roots, okay, and since it does just ask for the zeros, I don't need to write them as coordinates necessarily, although I could. And I'm going to write them in set notation, just with these braces here. And I'm going to go in order, saying that 1/2, 2, and 5. Okay, when x is equal to those are my zeros.